आवाज आ रही है सभी को अच्छी से? स्नेहा, प्रणाली,
Yes,
आवाज
ma'am.
आ रही है? ओके ओके
Yes, ma'am.
ओके ओके या ओके. So in today's session, we have to study about the Laplace transform, which derived by the Piri Simon. If you see, Laplace transform is nothing but it is an integral transformation of a function which can transform time domain into a complex frequency domain. It means what? By using Laplace transformation, we can solve differential equations and we can convert time domain into a, you can see here how we are converting. We can convert time domain into a frequency domain. T is nothing but we are taken T for the time, and f of s is nothing but function of s. We are calling that as a complex function because s is having the value sigma plus j omega, and if you see j is nothing but the complex value. That's why we are taking it is as a complex variable. So what we can say about the Laplace transform. Laplace transform is used to derive the differential equations because we can solve differential equations by using the Laplace transform, and it is very much having easy as compared to the Fourier series. That's why we are using the Laplace transform. Pranali, are you there?
Yes, ma'am.
You have studied about the Laplace transform Fourier series in mathematics 8 or not? तुमने ये पढ़ा है या नहीं
Uh,
पढ़ा है?
अभी तक नहीं मैम, मतलब
तो नहीं.
डिप्लोमा में था लेकिन अभी नहीं.
Okay, diploma में था. तो do you
हाँ
have any idea about how we are taking the Fourier series and the Laplace transform? उतना मतलब थोड़ा तो आइडिया होगा ही ना?
हाँ मैम, थोड़ा थोड़ा है याद.
Okay, okay, ठीक है, it's fine. You can mute yourself. Okay. So what? If we are using the Laplace transform, we will get solutions very easily. So we can use Laplace transform instead of the Fourier series. If you see, there are lots of limitations Fourier transform is having. There are many functions for which we cannot apply Fourier transform. That's why we can use Laplace transform here because it is applicable to each and every transformation, each and every functions. If you see, using Fourier transformation, it is little difficult to calculate the convolutions and to obtain the system response. So these are the limitations of the Fourier transform. If you see the differential equations with initial condition, we cannot solve by using the Fourier transform. But if you see here in the Laplace transform, we can solve the differential equations which are having the initial conditions. So there is a need of the Laplace transform. Laplace transform reduces the problem of solving differential equations to algebraic problem. So we will get the solutions of differential equations very easily by using the Laplace transform. So many mechanical and electrical forces are discontinuous in nature, or they may be present only for short amount of time. So these forces are not sine or the cosine functions. The solutions of these functions are very difficult, but by using the Laplace transform, we can convert these functions into a sine and a cosine functions. So we will get the simple solutions. So what we can say, we can use the Laplace transform to solve difficult differential equations in very simple way. Both complementary as well as particular solutions can be obtained in one operation by using the Laplace transform. So we can say about the Laplace transform, like Laplace transform give us the complete solutions for the differential equations very easily. If you see, we will get the solutions which can convert time domain value into a frequency domain, and this frequency domain is having the complex variable. We are calling that as a s equal to sigma plus j omega, and it is a complex variable. If you see, we can obtain Laplace transform for each and every function. We can convert time domain value into a frequency domain if we are taking the impulse function. delta of t. And if you are converting that value into a frequency domain by using the Laplace transform, you will get dou of t equal to f of s, that will be 1. It means what? By using the Laplace transform, you will get how to convert time domain into a frequency domain. If you are taking like delta of L d by dt of f of t. It is a simple function. If you are taking the Laplace transform, you can write that function in that way. Yes, f of yes minus f of 0 minus. And we are taking here 0 minus. It means what? It is its initial conditions. It's initial condition. If you are taking the derivative, that time you can take s into f of s. And if you are taking the integration, you can see here on the second line. If you are taking the integration, at that time you are supposed to take f of s upon s. If there is a integration, and if there is a derivative, at that time you can multiply f of s by s. और यदि इंटीग्रेशन है तो f of s को तुम क्या करोगे, as it is you will put, but s will go to the denominator. You can take small s, I have written here capital, you can take small or the capital. If we are having the two functions that are having the variable of time domain, you can see here both are having the time domain, both are having the t value, but both are in the multiplications. So how we can take, if we are having f of t minus a into another function, any functions, u of t minus a, you can take that function as e to the power minus as. It means what? Explanatory functions into f of s. But when that value of a, that variable, is greater than 0, if that value of a is greater than 0, at that time you can take L f of t minus a into u t of minus a equal to e to the power minus as into f of s. Exactly opposite. You can see here, if this function is at here and you are supposed to take the integration of this, instead of yes, there is a t function, because what? We are converting time domain into a frequency domain. तो यहाँ पे क्या आएगा, e to the power minus at. If you are taking the Laplace of e to the power minus at into f of t, you will get the same function, but here, irrespective of, here if you see, there is a time domain, but what we are doing, we are converting time domain into a frequency domain. So you will get here capital F, that is nothing but the frequency functions, and here that value minus will be go to the again minus, so that will become minus minus a, it means what? Plus a. So you will get Laplace of e to the power minus at into f of t equal to f of s plus e. Like this you can convert any time domain functions into a frequency domain. जैसे तुम डेरिवेटिव इंटीग्रेशन के लिए जैसे रूल यूज करते हो, these are the standard rules, these are the standard rules how we are converting time domain functions into a frequency domain. If we are having e to the power minus at, at that time you will get 1 upon s plus a, time domain into a frequency domain. If we are having the sine wave, at that time you will get, जैसे तुम्हें डेरिवेटिव में साइन का क्या मिलता है, cos ओमेगा t into omega, if we are taking omega as a constant. Like this, if you are supposed to take the Laplace transform of the sine function, at that time you will get that variable constant term as in numerator, and in denominator s square plus that constant square. if यहाँ पे 80 है तो यहाँ तुम्हारा इक्वेशन क्या होगा, a upon s square plus a square. We are taking that omega as a constant as it is. If we are having the cosine functions, you will get, यहाँ पे ओमेगा था, ओमेगा की जगह there is a difference, you will get here the frequency function yes upon s square plus the constant term a square, मतलब constant term का square. If you are having w, you can take the w square. Like this you will get how to convert time domain value into a frequency domain. You will be needed these to solve the Laplace transform of the basic element. In our electrical circuit subject, we are using the passive element. Which elements we are using? Resistor, inductor, capacitor. So we are supposed to take, we are supposed to calculate, we are supposed to derive the Laplace transform or these functions. It means what? Firstly, we are supposed to consider what will be the impedance. At that time, you will get how to take the Laplace transform. जैसे तुमने RLC सर्किट में देखा है, how we are calculating the values for voltage and current. Like this, we are supposed to use Laplace transform in the electrical circuit to derive the Laplace transform of resistor, inductor, and the capacitor. If we are having the resistor, you know how circuit will look like. If there is inductor, there is capacitor. We are calling that as a, if we are calculating the impedance, we can denote impedance by Z letter. Already we have seen here only in yesterday's session, two-port network. We have seen about ये two-port network का ही part चल रहा है. Already we have seen how we are calling these as a impedance, and admittance is nothing but it is the reciprocal. We can denote admittance by Y letter, और हम impedance Z letter से denote करते हैं. So we can say impedance across the resistor, that will be ZR. Impedance across inductor, that will be ZL. So if we are calculating here Laplace transform, you will supposed to know how we are taking the time domain and how we are taking the frequency domain. So if we are talking about the time domain, how we can calculate if there is resistance, we can call that resistance as it is as a impedance. So we can take ZR equal to R. You can take in the polar value or we can take in the rectangular form. So if we are taking ZL, it means what? Impedance across the inductor, you will get J omega L. It means what? You will get that value in terms of the complex variable. And if you are converting J omega L into the frequency domain, you will get SL. And if there is a capacitor, at that time you will get 1 upon J omega C. Like जैसे हम resonant frequency draw करते हैं, FC, FL, 1 upon 2 pi XC, 1 upon 2 pi FL, like this. You will get here ZL equal to J omega L and ZC equal to 1 upon J omega C. If you are converting into a time domain, you will get 1 upon S. These are the standard rules when we are talking about the resistor, inductor, and the capacitor. Now we are supposed to see how, if there is a equivalent R, L, and C circuit, and we are supposed to derive Laplace transform considering initial condition. It means what? हमें यहाँ पे initial conditions भी consider करना है, and we are supposed to calculate the V and I by using the Laplace transform. हमें voltage और current derive करना है, but how we can derive? By using the Laplace transform. So if there is a resistor, at that time we know according to Ohm's law V equal to IR, you will get the value of voltage. So we can take VR of T. It means time domain. You can take R into IR of T. If we are taking in terms of frequency domain, तो T की जगह हम यहाँ पे F नहीं लिखते, हम क्या लिखते हैं? In the Laplace transform, we are writing frequency domain by using the letter S. So what will our equation become? VR of S equal to R IR of S. If you are calculating about the capacitor, you can see here, if you are calculating here voltage, I have given here the name VR of S, IR of S, because we are calculating here the time domain, converting into the frequency domain. So I have written these values in the frequency domain. Now we are supposed to calculate the value of voltage for the capacitor. You can see here we are giving here one capacitor and one battery source, DC source we are giving here. So we can take capacitor, हम क्या ले रहे हैं capacitor को 1 upon SC, and if there is inductor we are taking as a SCL. So I can take as it is 1 upon SC, I can write here. And voltage across here we can take as a VC 0 minus, that will be a initial. And if you are taking its Laplace transform, that will be in the form of VC 0 minus upon S. So now we are supposed to calculate voltage. How will you get? You will get here VC 0 minus, ये जो यहाँ का है. Again, we know how you will get voltage across this capacitor. Already we have seen in the RC circuit. We can take integration 1 by C, integration 0 to T, IC to dt. In that way, we will get the voltage across that capacitor in the time domain. If you are calculating in the frequency domain, you will get Vc of S equal to Vc 0 minus upon S, because I have written here in the frequency domain. ये 1 by C को क्या आएगा? 1 by S into C, and we can take this integration as a IC S. These are the standard rules and these are very simple. If anyone is facing any issue, you are not getting any point, you can unmute and you can ask me the question. Okay, if you are calculating the current, in which domain? In the frequency domain. In time domain, you will get C dVc upon dt. How you will get? Because we know Q is nothing but Q equal to CV, but dQ by dt equal to I. We have seen this concept in the RC circuit, or we are using the same concept for the time domain. And when we are converting the time domain into the frequency domain, at that time we are using the rules which we have given here for the frequency domain. ये जैसे हम टाइम डोमेन के वैल्यू फ्रीक्वेंसी डोमेन के लिए यूज कर रहे हैं. सो आई एम राइटिंग एज इट इज. So if there is an inductor, we are taking that inductor as in a frequency domain as S into L. And if it is in a time domain, how we can calculate the voltage? We can calculate voltage as L di by dt. So now we can convert that value into a frequency domain. How we can convert? VL of S, T की जगह आएगा S, into SL, that as it is. Yes, because we are taking their current IL of S, minus L IL 0 if you are calculating there the voltage. And if you are calculating the current, how will you get? You will get the current as, you can see here the circuit diagram, how we are taking in the time domain and how we are converting that value into the frequency domain. So we will get the values for current also, like I of S equal to VL S upon SL plus IL 0 minus upon S. You are supposed to study, you are supposed to practice these derivations at your home. At that time only you will get how we are converting. Okay. Swati Patil, is there any issue? Swati?
No, ma'am.
Okay. So you can see here, we can convert that time domain variable into a frequency domain variable easily, and we will get solution of differential equations easily. That's why instead of this time domain, we are using the frequency domain. By using the Laplace transform, we can see one example. If we are having one example in which they are giving here, sometime there will be question for the RLC, sometime there will be question for RC, sometime there will be question for the RL. You are supposed to understand how we are taking the values of voltage and current. You are supposed to study about these concepts, how we are taking, how we are converting time domain value into a frequency domain. You are supposed to understand these things. After that only you will get how we are supposed to solve these equations. If we are having here voltage, they have given 30 e to the power minus t. They have given here initial condition switch. And what we are supposed to do? Use the Laplace transform technique and determine the values of current for t equal to 0. If we are having the values of resistor, we are having the values of inductor. We know how we can take values of resistor. I can take directly 6 into I of S. If we are supposed to take the inductor, we can take S into I of S. But you have इंडक्टर का वैल्यू दिया है एल, एल का वैल्यू एज इट इज एल इंटू यस आई ऑफ यस, तो हम क्या लिखेंगे 3 इंटू यस आई ऑफ यस. नाउ वी आर सपोज टू टेक फॉर दिस 3 e to the power minus t, so we are having the rule e to the power minus et. What we can write 1 upon s plus t. So as it is we are writing 30 will be as it is, and e to the power minus 80 को मैं क्या लिखूंगी 30 as it is I have written here, and e to the power minus 80 if we are having, यहाँ पे minus a का वैल्यू क्या है -1, तो what will become here 1 upon s plus a, तो 1 upon s plus 1, so I can write here 30 upon s plus 1. If you are solving these equations, if you are doing the cross multiplications and you are solving, you will get I of s equal to 10 upon s plus 1 s plus 2. Again, you are converting that value into a time domain. How we can convert 1 upon s plus 1? How we can write? We can write e to the power minus t. तो मैंने क्या किया है s plus 1 को लिखा है e to the power minus t, 10 as it is because it is a constant. If we are having two terms, we can take here 1 minus sign. Again 10 as it is, 1 upon s plus 2. उसका क्या रहेगा? If we are converting frequency domain into a time domain, 1 upon s plus 2, we will get e to the power minus 2t. I have written the same. So firstly, we are supposed to study about this thing. If you will get this thing, at that time only you will get how to solve. You can see here 1 upon s plus a. If it is in frequency domain, you can write in the time domain e to the power minus a. So I am using this formula and I am solving that question. So here you will get 10 e to the power minus t minus 10 e to the power minus 2t. How we are doing? Firstly, we are converting network from time domain into the frequency domain. Then we are writing that equations. We are solving that in equations. We are writing these equations in the simple form. Again, we can convert LT to convert that time domain value into a frequency domain. हम क्या कर रहे हैं फिर से वो टाइम डोमेन वैल्यू को फ्रीक्वेंसी डोमेन में कन्वर्ट कर रहे हैं. सो यू विल गेट दिस वैल्यूज हियर. इफ एनीवन इज नॉट गेटिंग एनी पॉइंट यू कैन आस्क. और ये 30 s plus 1 6 is we will get by using the KVL. So we can solve and we will get here in the time. This is the time domain. We can convert that time domain value into, you can write here yes domain or you can write here frequency domain, F domain. So we can transform that circuit of time domain into a frequency domain as 30 upon s plus 1. Switch, there is no need because we are converting that switch in the on conditions because they have given here. You are supposed to use the Laplace transform to determine the value of current when time is greater than 0. So we can take that switch as a closed switch. So I am taking as directly closed wire. We can take that 6 ohm as it is and you can use in time domain as a 3 Henry, but if you are converting into a frequency domain, you are supposed to use here 3 yes. So I am writing here 3 yes. Now, if example of a partial fraction expansion of simple and the complex. I have given here one example only and how we are converting. If anyone is facing any issue in this question, then you can ask me how I am taking these values. Firstly, किसी को doubt है तो पूछ सकते हो. प्रणाली, योगिता, are you there?
Yes, ma'am.
हाँ, ये समझ में आया how I am taking the Laplace transform and how I am converting time domain into a frequency domain. ये समझ में आया?
Yes, ma'am.
Okay. Okay. So now we will see about this. So if we are having the function like this, I am giving here only to understand the things, how we are converting. If we are having the function s plus 5 f of s, where s equal to minus 5, we can write that equation as s plus 3 upon s minus 5 s square 4s plus 5. What I have done here, I am writing this as it is. But if you solve this, you will get here s plus 3 will be, we are multiplying numerator and denominator by s plus 3. You will get the same value. You will get s plus 5. If you solve this, you will get here s plus 5. If you are taking here s equal to minus 5, you will get the value minus 0.2. If you are converting that value into the complex form, you will get, if you are taking one example a2 s plus 2 minus j, if you are taking in the complex form and you are taking here s equal to minus 2 plus j, ये जो साइन होता है उसके ऑपोजिट वी आर टेकिंग द वैल्यू. यहाँ पे प्लस 5 है तो तुम यहाँ पे s इक्वल टू माइनस 5 देखो. यहाँ पे s प्लस 2 माइनस j है तो यू कैन टेक s इक्वल टू माइनस 2 प्लस j. If you are taking s equal to minus 2 plus j and you are putting their value, you will get this equation. If you are solving minus 2 plus j by putting s equal to minus plus 2j, you will get 0 minus 1 minus 0 minus 2j. It means what? You can take the frequency domain value into in terms of the complex variable. If we are having that value s plus 2 plus j, you can take minus 2 minus j, you will get this value, and that will be the inverse of this, because you are taking here 2 minus j, but here you are taking 2 plus j. So opposite it. It means what? You will get here 0.1 as it is, but minus 0.2j था तो यहाँ पे आएगा 0.2j. How we are taking the frequency domain value into a complex variable? In that way, I am just explaining how we are supposed to convert. If we are having another example, like we are having this example, I am taking the random questions. So if we are having these questions, you know how to solve. How we can solve? We must use two terms for the partial fraction. We know how to solve the partial fraction. What we can do here, if we are taking here 6x plus 7 as it is, and we are taking x plus 2, we are taking to the right side, your equation will become x plus 2 यहाँ पे एक है तो यहाँ का एक कट हो जाएगा. You will become here only 1x plus 2 will be remaining. So you will get a x plus 2. x plus 2 square यहाँ है तो you will get here cut x plus 2 square numerator denominator का कट हो जाएगा, b रहेगा. If you solve, you will get the value for a and b. You can put this value and you will get the solution. If you are getting that partial fractions, you can solve that value to get the values for a and b, and you can put this value in the equations and you will get the simplified equations. So here we have finished network function. We can take in the next class now. Yeah, okay. So we can convert any partial fractions into the simple equations by calculating the values of that variable. Here we have finished about the Laplace transform. Now we are supposed to study about the network. We will see in the next class, network functions. If anyone is facing any issue, you can ask me. Now I am taking your attendance. You guys can leave now. Thank you.